Bhupender Singh.
Hi, hi,
Hi.
good evening.
We will wait for some more time for more people to join and then we can proceed, I guess. Is that fine?
Okay, okay. Yeah,
We,
it's fine. No?
yeah, maybe we'll wait until 7:05 and check if more people are joining. Then we can start the session.
Okay, okay.
Thank you. Chalo, it's already 7:05, so now shall I start the classes? Kindly someone respond. Am I audible?
Yes, you are
Yes,
audible.
ma'am.
Okay, okay, thank you so much. Okay, so now I'll start. First, let me introduce myself. I'm Shiva Shankari. I'm a PhD scholar in IIT Madras. I'm the person who is handling all the live session for this NPTEL course, Biological Process Design for Treatment of Wastewater. So now let's begin with the lecture. Is my screen visible?
Yes, ma'am.
Yes, yes,
Okay.
it's visual.
So, welcome to live session 3 for biological process design for wastewater treatment. So, I'll solve some questions Like today it will be maximum full of numerical problems, so like I want you people to like interact with me if you have any doubts, or in between also, like we can have proper interaction because it's majorly numerical session. Okay, so beginning with the first question, a treatment unit is 2-meter wide, 30-meter long, and has a wastewater depth of 3-meter in it. If the wastewater flow through the tank is 0.6 meter cube per second, calculate the detention time in minutes. Does anyone know what is the formula? Can someone respond, Pooja? Can someone respond what is the formula that relates between the flow, volume and time? Bhupender Singh? Okay, then I will tell the formula. So the given thing is like it is 2-meter wide, 30-meter long, and the depth of wastewater is 3 meter. The flow is 0.6 meter cube per second. The detention time is we have to find. So initially, the formula that relates flow, volume and time is flow is equal to volume divided by time. Here the flow is given in meter cube per second, but we need detention time in minutes. We can find the volume by length into breadth into depth. Since it is a rectangular uh, tank, as three dimensions are given as length, breadth and this depth, so the volume will be uh, time is equal to volume divided by flow from the formula, which is we have to find the time we have to find. So the volume will be 2 into 30 into 3, which is LBH, divided by flow. The flow given here is 0.6 meter cube per second. So if you substitute, you will be getting 300 seconds and the answer will be 5 minutes. Does anyone have doubt in this?
No, clear.
Okay. So, in this, the option will be option B, 5 minutes. So, now we'll move to the next question. The enzyme catalyzed conversion of a substrate at room temperature has a Ks of saturation constant as 0.045 molar. So the rate of the reaction R is equal to 1.2 into 10 to the power minus 3 per second. When the substrate concentration, that is S substrate, is given as 0.1 molar, what is the maximum reaction rate? That is R max. We have to find. So does anyone know what is the formula that relates all these parameters? Does anyone know? Pooja?
Yes,
Can,
ma'am. I think we had to calculate mu max value, na?
mu max value. So you know the
To
formula, right? Can you tell me the
mu
formula?
equals mu max into substrate divided by Ks plus substrate.
Excellent, excellent. So can you just make substitutions and
Yes,
let me
ma'am.
know the
Just a
answer?
second.
Yeah, yeah, yeah. Take your
One
own
second.
time. Yeah, yeah.
Okay.
Does everyone know the formula, or should I project the formula?
Please project
Ma'am,
the
please project the formula.
I can repeat the formula. Wait. So
Yes, ma'am, please.
wait. I'll tell. See here. In question, what all things are given? Ks is equal to 0.045. Okay, please write the given. Okay, or you can write as mu equal to 1.2 into 10 to the power minus 3 per second, and S is equal to 0.1 molar. Okay. Okay, I have like shown the answer also, but that's okay. The formula is R is equal to R max into S divided by Ks plus S. Now you have to find what is R max. That is maximum reaction rate or growth rate. As Pooja told, was telling using growth rate, that is mu, but we can consider it as reaction rate R max also. So just find R max from the formula and make substitutions and tell me the answer, please. I have projected the formula also. After making substitutions, you can tell the answer. I'll give some 2 minutes time. It's 7:12 now. I'll ask the answer at maybe 7:14. Ks is 0.045 plus S is 0.1. So Ks plus S is equal to 0.145 into R is 1.2 into 10 to the power minus 3 divided by 0.1.
Ma'am, would you please show me the options?
Yeah, sure, Pooja. 1 second. It's 1.74 into 10 to the power minus 3, 3.87 into 10 to the power minus 3, 2.4 into 10 to the power minus 3, and 4.8 into 10 to the power minus 3.
Ma-
Uh,
Ma'am, it's
Option
A.
one.
ha,
Option one, ma'am.
yeah. It's correct. Option 1 is correct. Even I'm getting the same answer. So, have you all done the problem, or should something be explained? It's direct substitution only, no? Is it fine for everyone? Bhupender Singh?
Yes, I already
Okay, cool.
told the answer, ma'am.
Okay, fine. Now so the answer is 1.7 into 10 to the power minus 3. Now I'll move to the next problem. Given an ideal plug flow reactor under a steady state with volume is given as 4000 meter cube with influent flow as 800 meter cube per day and substrate concentration as 300 gram per meter cube. If K equal to 0, that is for a conservative substance. Find the concentration along the tank at the time T. Okay. So conservative substance is a substance. I mean, it is a pollutant that cannot be destroyed or degraded or chemically transformed, or even volatilization is not possible. under the conditions in which wastewater treatment plant exists. Okay, so that is called as a conservative substance. So what will happen with respect to time? The bacteria cannot eat, it cannot get volatilized also, it cannot be chemically transformed also. So what will happen to a conservative pollutant? It can only settle, it cannot like reduce in concentration. Hana? So, do you know what is the formula for plug flow reactor with respect to time? Does anyone know? Pooja?
I don't think so. I know that.
Okay, no problem. Then I'll project the formula. You people can like make substitutions. So, okay, 1 second. So, this will be the formula. C is equal to C naught into e to the power minus kt. So, C is what you have to find, the concentration along the reactor. So that's what you have to find. For a conservative pollutant, K is equal to 0. We know that. Substrate initial concentration is given as 300 gram per meter cube. Influent flow is not required for this question. So, like, can you make substitutions? C is equal to C naught into e to the power minus kt. I'll give 2 minutes time. You can just like now the time is 7:18. I will come back at like I'll ask back at 7:20. Can like you people can respond. Okay, can someone tell the answer? Pooja?
No, ma'am, actually, I don't know the concept of this formula.
Are Baba, just make the substitutions and tell me.
Actually, ma'am, it's not clear here. So, what is the value of the C dot and
Okay. Are you could have asked me now. C naught is initial substrate concentration. Okay, that
Substrate concentration.
substrate concentration that is 300. Okay, E is that 3 into 10 to the power. You will have that exponential function in your calculator. Now that one. K equal to 0 and time is equal to 1 second. K is equal to 0. So obviously E to the power 0. Okay.
so what is the function of volume here? Like you have mentioned the volume.
Yeah,
So
yeah,
we have
that's
already given a
yeah, yeah,
volume.
yeah, that's what I'm telling. See, volume, inflow rate, and all the same question. No, we have to find different things. Okay, I have organized in that way. First thing is for a plug flow reactor, what will be the concentration along the reactor? For this same given data, we will be finding some other things. That's why it is like redundant data that is not required here. Okay, so here if you see,
Okay.
I mean, you are getting now what I'm telling. It
Yes,
is
yes.
redundant data, extra data. See, in your exams also, what they will give is they will give too much excess data that is not at all required for you. So that like you people think like and get confused. Okay, this is given, we have to apply it somewhere, something like that. Okay, here actually that is not required. But thing is, you can find T with that. Okay, but here that is not required since K equal to 0. Uh, See, Q is equal to V by T, Hana. So you can find T is equal to V by Q. That is that is your volume will be 4000 divided by 800. So your time will be 5 days, Hana. So it is C naught into e to the power minus 0 into 5. Here this 5 is not at all required because you know e to the power 0 is 1. You are getting what I'm telling? Hello? Can someone respond?
Yes, yes, we are getting.
E to the power, here k is equal to 0. So this time is not at all required. So C naught into 1 because e to the power 0 will be 1. So C naught is equal to C, that is equal to your 300. Are you getting?
Yes.
Okay, fine. Pooja, did you understand, Pooja?
No, ma'am. Actually, I don't know the plug bioreactor concept.
Okay,
Actually,
okay.
it's
I think it's
that's why
lecture.
that.
I think it should be lecture
The,
15, lecture 14
yes,
or
ma'am. Yes, ma'am.
it's fine, it's
Uh-huh.
fine. You just make the substitutions. That's enough.
Uh-huh. Okay, okay,
It's like
okay.
you don't have to it's okay even if you don't watch the lecture. No, I'm giving the formula,
That
right?
that's lecture I have not attended right now, but after that I will be available, capable to do this.
Yeah, yeah, no problem. You know the formula, right? I have projected the
Yes,
formula.
ma'am.
You just
Yes,
like
ma'am.
make
Yes, ma'am.
substitutions. Yeah, that's enough. Yeah. You can watch the lecture later, and if you have some doubts in lecture also, you can ask me. Okay.
Yes, ma'am. Okay.
Okay. Now I'll move to the next problem. So the answer will be 300. So moving to the next question, I mean, it is the same question, but here the pollutant is not a conservative pollutant. It is non-conservative. With the degradation rate constant, K is equal to 0.4 per day. Okay. So now you have to find the hydraulic retention time in days. Okay. So can you people find it? Here it is like it is in series. Okay, series in sense like the flow will be divided into two and given to two tanks. Okay, so I'll project the formula. You just, even if you didn't watch the lecture, just make substitutions in the formula as of now and then you tell me the answer. Okay, is that fine? Can someone
In this
uh,
only we had to calculate a hydraulic detention time only.
yeah, only hydraulic retention time in days.
It's V upon Q,
Yeah, yeah, that's
normal
it.
formula.
Yeah, that's it.
Okay.
Divided by 2.
Okay.
Since it is like 2 reactor, no? The flow gets splitted into 2.
Okay. 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 Okay, ma'am.
Okay,
Okay.
so just make substitutions.
Three
That's it.
3.5.
It's 3.5. Yeah. Okay. Because volume is equal to 2800, influent flow rate is equal to 400 meter cube per day, substrate concentration is 300. Here these are all redundant data. See here, substrate concentration and this K, everything is like redundant data. It's just a matter of common sense. You yourself will know like what is like Q is equal to V by T, that's it. So from that you
So
can find T.
so both these reactor are in a series, na? Yeah,
Yeah.
yeah, parallel.
Parallel. Yeah.
Okay.
Okay. Because the flow is getting splitted into two. Okay. If the flow is getting splitted into two, it is Q by 2. So that's why
But
I
it's
have
the
given Q by N.
but both the reactor are in a series, na? So let's say if, the total volume of both the tanks is 2800. So if inflow rate is 400 meter cube per day.
Uh,
So I think it would be considered as a one reactor.
uh,
So
uh,
in
uh,
that case,
uh.
I think retention time would be the 7 days.
1 second. Yo,
It's in a
okay.
series, na?
Yeah. I understood what you are telling. Yeah. If it is in series, yeah. Fine. Understood. Okay. So that is the thing. Now we'll move to the next uh, question.
So what would
Assist
be the right answer? 3.5 or 7 days?
7 days, 7 days, 7 days.
Okay.
No, okay. It's 7 days. So again, now we'll move to next question. A system with two cells in series has a volume of 2800 meter cube. The influent flow is Q is equal to 400 meter cube per day, and the substrate concentration S is 300 gram per meter cube. Assume the cell is an ideal complete mix reactor in steady state and the substance is biodegradable with first order removal K equal to 0.4 per day. The concentration in the second cell they have asked. Okay, so I'll show the formula. So the formula will be C is equal to C naught divided by 1 plus KT the whole square. This formula you will be able to see in the lecture. So don't like think too much. I have given the formula. You just make the substitutions and tell me the answer. Okay, is that fine? Can
It's
some
fine.
yeah, because these things you will be able to derive and do and all only if you have watched the lecture, but that's okay, no problem. Even if you don't watch lecture, if you didn't watch lecture, you can watch later also. I will give the formula, just make substitutions and tell me the answer. Okay, so I'll give 2 minutes time. Now the time is around 7:30. At 7:32 I'll ask the answer. So the formula is C equal to C naught divided by 1 plus KT the whole square. C naught is the initial concentration, that is substrate concentration. It will be 300. Okay. And 1 we can write it as such. Since it is a non-conservative pollutant, the K reaction rate constant is given as 0.4 and this 3.5 is taken from the previous problem. What you do is you consider this previous problem as parallel, not in series. Okay, if it is in parallel, you will be getting the value as 3.5 only. So just make substitution as 3.5 and tell me the answer. Because I have solved it.
50,
Because I have solved it that
52.08.
it's fine, 52.08. Because I have taken that previous problem value for the consecutive things. So it will be better if you consider that as this thing. Okay, so it is 52.08. Has everyone got this problem correct? Or should I explain something? Pooja?
Yes, ma'am, got it.
Okay. Chalo, I'll move to the next question. Right. Okay. A system with two cells in parallel, that is, okay, has a volume of 2800 meter cube. The influent flow is 400 meter cube per day and the substrate concentration is 300 gram per meter cube. Assume the cell is an ideal complete mix reactor in a steady state and the substance is biodegradable with first order removal as K is equal to 0.4 per day. Calculate the concentration in gram per meter cube in the second cell. So the answer is 52.08. Okay, so note this answer. The final concentration is 52.08 because for next question you will need this answer. Like the way I used the time in the consecutive problems now. So the final concentration C is equal to 52.08. Everyone please note it down because you will require it in the upcoming problem. Next problem. Have everyone noted it down?
Yes, ma'am.
Okay, chalo. Now I'll move to the next problem. Okay. A system with two cells in series has a volume of the same volume. The influent flow is 400 meter cube per day and the substrate concentration is 300 gram per meter cube. Assume the cell is an ideal complete mix reactor in a steady state and the substance is biodegradable with first order rate constant as K is equal to 0.4 per day. Find the removal efficiency. Does anyone know what is the formula for removal efficiency?
Ma'am, it's C node minus C final
Ha,
divided by C node.
into 100 percentage. Okay. Uh, can you make substitutions and tell me the answer?
Okay,
UCF
ma'am. Yes, ma'am.
UCF as 52.08 taken from the previous problem. Okay, and UC naught as 300 gram per meter cube. Okay. I have shown the formula and substitution also. Just make the substitution and tell me the answer. I'll wait for 2 minutes. Now the time is 7:33. I will ask at 7:35.
Ma'am, please show the options.
Yeah, sure, Pooja. It is 56.24, 77.39, 45.98, and 82.6764.
82.64.
It is correct. Have everyone got the same answer? Pooja?
Yes, ma'am. This is the exactly answer.
Okay. Sneha? Okay. Fine. The answer is 82.64 percentage. Now we will move to the next question. So the answer is 82.64. Okay. So this is a theoretical question. What is growth yield defined as? Can someone tell me the answer? What is meant by growth yield? That is Y. It is a biokinetic parameter. Yield. Pooja?
Yes, ma'am. Just I am reading the options.
Okay. Take your own time to read the options. Okay. Now the time is 7:36. You people just like try to read the options and understand. I will ask back in some time. 738 I will ask. Growth yield is Y.
Ma'am, it's C. Difference between biomass production and substrate consumption.
No, Pooja, it's not the correct answer.
I think A.
It's amount of biomass formed
It
per unit amount of.
option A.
Option A is correct. Yeah. Biomass produced per unit of substrate consumption.
That's it.
Okay, okay, no problem, no problem. Yeah, it's like how much biomass, that is, your bacteria will be produced, right? There will be initially certain amount of bacteria. That bacteria will consume the substrate. The substrate can be your COD or nitrate or something like that. So it will consume the substrate to reproduce and make more cells. Okay, so it is basically like how much yield. No, it is like we can define as usually, generally in engineering, how you measure yield is like what is the output that you get divided by what is the input that you give. Okay, so here, what is the output we are getting? It is the biomass that is getting produced. So that will be the output. So it is dx. Okay, and the substrate that is getting consumed, that will be your input. Okay, so always remember, when it comes to engineering, yield is defined as output divided by input. So here it is biomass produced per unit of substrate consumption. Okay, so the correct answer is option 1. If you see, in case of nitrifiers, they usually consume nitrate. They don't consume carbon. है ना? So in case of nitrifiers, the substrate will be nitrate nitrogen. Okay, so kg of biomass produced uh, divided by kg of nitrate nitrogen that is getting consumed for the case of nitrifiers. For the case of heterotrophs, the yield will be kg of biomass divided by kg of carbon substrate. In case of heterotrophs, carbon is the substrate that is getting consumed. So it is like yield will be like the weight kg of biomass that is produced divided by the kg of carbon substrate that is being consumed. Okay. When it comes to hydrogenic methanogens, the yield will be the weight of biomass produced divided by the weight of hydrogen they have taken in. In case of hydrogenic methanogens, the substrate will be hydrogen. It won't be carbon. So it is like kg of biomass divided by kg of hydrogen. Okay. So now we'll move to the next question. Can someone tell what is the correct relationship among these four options? I will give a hint. There can be 2 or 3 options correct also. Okay. So this is basically the Monod's equation. So I'll give some time. Now the time is 7:40. You people just write the Monod's equation and try to rearrange it and check which options are correct. I'll give some 2 to 3 minutes time. Now the time is 7:40. I'll ask back at 7:43. It is the Monod's equation. I have given the hint. And the answer could be like 2 or 3 options also. You don't have to stop with a single option. So please write and check.
B and D.
Which options?
B and D.
B and D. Okay. Can some do you have? Okay. Okay. Someone is trying to speak. Do some others have some other option? Okay. The correct answer is A and D.
A and D.
A and D. It's not B and D. Okay. You just have to like see R is equal to R max into S divided by KS plus S. So you have to find R max from this. So R max will be equal to R into KS plus S divided by S. So the options will be A and D. Chalo, now we will go to the next question. So the next question is like, when including endogenous respiration, the production of net solid becomes uh, just try to recollect the equation. I'll give some 3 minutes time. Now the time is 7:42. Basically what you have to do is you have to relate the biomass production X. 1 second. So basically what you have to do is you have to try to relate the biomass production rate, that is dx by dt, with the kd, that is the endogenous decay constant, and substrate utilization rate dx by dt with yield.
Ma'am, it's A.
Can you explain why it is A?
Can you explain why it is A? No, ma'am. I don't know in detail, but
Okay, no
I think
problem.
it's A.
Okay, no problem. Okay, no problem.
Okay, no problem. Okay, no problem.
Okay, I'll explain. So dx by dt is equal to y into ds by dt minus kd into x. Uh, you know what is y here? Y is
No,
yield,
ma'am,
right?
please explain.
Y is yield. Okay.
Okay.
Okay, y is yield. That is what like I was explaining in the previous question, right? Like what is y? Y is biomass produced per unit of substrate consumed. Okay, so your y will be equal to biomass produced. Rate of biomass production is dx. Okay, and substrate consumed, it is ds. So dx by ds will be your y. So everyone please note down, y will be dx by ds. Okay. You all know what is meant by endogenous respiration. Does anyone know what is meant by endogenous respiration? I think it should be given in lecture 12 or 13, I guess. Okay, fine, no problem. See, what will happen is the bacterial growth, no? Do you people know the bacterial growth curve? Did anyone watch lecture 12 or 13? Okay, no problem. It's fine. I will explain what is this bacterial growth curve. Initially, no, what will happen is the bacteria uh, will be in lag phase. See, what you are going to do is you are going to put a bacteria to eat your pollutant, that is your carbon. Okay, that is what is happening in ASP and all. You are putting bacteria so that they consume this carbon and then they produce more cells. Okay, so this bacterial growth curve for batch in batch reactor, how it will be is, initially the bacteria will be in lag phase, then it will go to log phase, and then finally it will go to this kind of steady state. Wait, maybe I can show some picture from internet. So this will be the bacterial growth curve. So initially what is happening is, it will be in lag phase, then it will reach the log phase, then the stationary phase, and finally the death. Okay, this is true for a batch reactor. Okay, in a batch reactor, no, there won't be any input or output, just the concentration of the carbon will be remaining constant. So initially in the lag phase, the bacteria will be like, when you like just put it into a different environment, it will be in a reluctant position to grow. So that is the lag phase. Then after some time, it will get used to the environment. So what will happen is, they will try to get multiplied into numerous number. Okay, so it will reach the log phase. So they will try to, like, what to tell, they will try to multiply more in number, and the reproduction will be increasing, and the cell density will increase like anything. After that, it will reach the stationary phase. In case of stationary phase, the bacteria won't reproduce. It will just increase in its size. It won't produce more cells. So in stationary phase, that is the thing that will be happening. And in case of the endogenous phase or the death phase, what will happen is, the bacteria the bacteria will start consuming its own dead cells. So that is called as the endogenous respiration phase. Okay, so in case of log phase, it is increasing, that is the rate constant for bacterial reproduction, that is Ka, will be positive. But when it comes to the death phase or the endogenous respiration phase, it will be negative. So that is minus Kd. That's what I have represented here as minus Kd. Okay. So, but as a whole, if we consider, the net bacterial growth rate will be equal to dx by dt. Net will be equal to your ds by dt. Your ds by dt into yield, that is dx by ds, minus kd into x. That's how this kd comes into picture. Okay, that is, it will be negative slope, that's why. Okay, so if we consider the endogenous respiration also, the death growth rate will be ds by dt into dx by dt into dx by ds, that is your yield, minus endogenous respiration rate constant into x. Is it clear? Or should I explain once
Yes,
again?
ma'am. Yes, ma'am. It's clear.
Okay, okay. Someone wants it to be explained again. Okay, I'll explain again. Here it will be Kd negative. This is for KD. Okay. This will be negative since it is decreasing. Okay. So if you consider yield, Y is equal to ds, no, it is dx by dt. Second, it is dx by ds. That is biomass produced, divided by substrate consumed. You have to find dx by dt. This is dx by dt net. Okay, that is net rate of growth of biomass. Okay, this will be equal to your total dx by dt by dt total minus dx by dt due to endogenous death. Is it clear up to now? Is it clear up to this step?
Yes, ma'am.
Huh? Your total growth rate will be, your net growth rate will be equal to your total growth rate minus endogenous growth rate. Okay, because the total growth rate will be total amount of cells produced. But in case of endogenous respiration, after some times, some cell will be consumed by the bacteria itself during the endogenous respiration due to the reduction in substrate. Okay, since it is a batch process. So your total dx by dt minus dx by dt endogenous respiration. So how will you write dx by dt total? Do you have any idea how to write dx by dt total? Okay, fine. Let me explain how to find that also. I'll like I'll move to a new slide and then explain. So it is dx divided by dt total. This is what you have to find. Okay. This is dx by dt total. Okay. So dx by dt total you can find by ds by dt. Okay. It's a bit tricky. ds by dt into your dx by ds. Dx by ds. Okay. So this will, what is dx by ds? Can someone tell me? I have explained in previous problem, no? What is dx by ds? Can someone tell me? Pooja?
Ma'am, DS is the total substrate consumed.
Ha. dx is
And
biomass produced. So
biomass produced.
biomass produced by substrate consumed. What is it?
It's a growth yield,
Yield.
no?
Exactly. It's the yield. Okay. So this will be your yield. So dx by dt total we know. Okay. It is ds by dt into yield, that is y. Okay. Now you tell me dx by dt endogenous, what will it be? Can someone tell? See, rate of the reaction is equal to rate constant into the concentration present at that moment. Okay. Basically, if you see a reaction rate, that is dr by dt. Okay. Reaction rate. See, you can consider it x itself. dx by dt is equal to some k into x. Okay. This is the usual thing for a first order reaction, right? You consider this as first order. That is the rate at which the endogenous respiration takes place. Let us consider it as first order. Okay. So it will be like k to the power 1 into x. So what is k in endogenous respiration? In death phase. I have given here now. Can someone tell what is K in case of endogenous respiration, that is death phase? Snegha? Pooja?
Ma'am, it's bacteria consumes its own cells.
That is
That's why
okay.
it's in minus.
It's in minus and the
It's a
rate
minus
constant is
and the
KD.
rate constant is KD.
Hana? The rate constant
Ma'am,
I have given it
please
as
repeat.
KD.
Uh-huh.
Yeah, Pooja, tell me.
No, ma'am, it's okay.
Yeah, tell me, Pooja, if you have any doubt.
Ma'am, actually, your voice was echoing. That's why I'm saying, ki, ma'am, please repeat it again.
Oh, okay. Okay, fine. Should I explain it again from the beginning?
No, ma'am, just the minus KD. I'm saying that it's the bacteria growth consume its own cells. That's why it's
Yeah.
in minus.
Yeah. That's why it is
Yeah,
in minus.
That's why it is in minus.
See,
See,
when your bacterial
when
cell
the
is getting
bacterial cell
consumed,
is getting consumed,
Pooja, can you mute it so that like the echoing reduces? Okay. See here, the bacteria is consuming its own cells. So what will happen? The cell number will get reduced. That's why it is negative. Okay. Pooja, did you get what I'm telling?
Yes, ma'am. Yes,
yes,
ma'am.
ma'am.
I got it.
Okay. So it is minus negative KD. Okay. So if you see here, for endogenous respiration, it is going to be Kd into X. And this will be minus Kd into X. So it is minus Kd into X. So now can someone tell me what will be the net yield? Net yield will be total yield minus endogenous yield. See here. Dx by dt total minus dx by dt endogenous respiration. Dx by dt total, what is it? From this slide you can get. It is ds by dt into yield. it is ds by dt into yield minus your kd into x. Okay. Now did you people understand how you got this equation, or should I explain it once again? So the answer will be first option. Is it fine, or it has to be explained once again? Pooja?
No, ma'am. The X value is the concentration of microorganism, na, which are present in that
Microorganism.
reactor.
Yeah, microorganism.
Okay, okay, okay.
See, here your microorganism is consuming its own cells in endogenous respiration phase. That's why it is minus
Mm-hmm.
kd into x. Okay, I'll explain once more so that like you people get it like clarified properly. See here, it is dx
Ma'am,
by.
I got it. I
You
got
got
it,
it?
ma'am. I got it.
Sure. Is
Yes,
it
ma'am. I
fine?
got it.
Okay. Fine. Chalo, no problem. If you have any doubt, no, feel free to ask. I don't have like any hesitation to explain again and again, because at the end of the day, it's like you people who come and attend the live session, you should be benefited more. That is the idea.
Actually, ma'am, that's the confusion. Na. Actually, I haven't attended that last week session. That's why it's something
Okay,
hard
no.
for me.
Okay, no problem. No, that is not an issue. You can see that's why like we give the video for like I mean you can understand that now you can watch your video like whenever you want. So it's fine.
No,
Like
ma'am. Once I will go through the videos. Na, then after I will be more comfortable to give the
ah
reasons and answers.
okay. No problem,
Yes,
no
yes,
problem.
ma'am. Same thing has happened with me. I've joined late, no, so I've missed many lectures. So I'm watching lectures from first. So it is a bit
Okay.
difficult for me to answer. But as
Understood,
soon as I
understood.
finish, I will be able to answer. Yes, ma'am.
Okay. No problem. It's okay. I will explain. Like if you watch lectures after this also, you can like get better understanding, because at least you will get some idea like what is there. So that's okay. No problem. Okay. So now I'll move to the next problem. I mean next question.
Ma'am, I have just a question.
Yeah,
Now
Pooja.
that we are in a third week session, na, so there is so many formulas, so many concepts are there. So
Okay.
in the exams, how we remember that kind of formula should be implement here. It will be so
Uh,
typical.
yeah. You try to
Is
practice with more problems.
uh,
See,
mm-hmm.
it's like it will be like easy once you get used to it more and more. Hannah, see, it's like initially like not everyone, or like even I felt like too difficult to like study all these things. Okay, you people are in BTech only, right? So it will be difficult only. So what you do is you write and see the problems and formulas. Okay, like what to tell. Uh, Instead of like seeing as such, you make a formula sheet or something like that, and you just see the formula for some time in a day, like 5-10 minutes. Once the lecture is over, no, you just try to like, even the transcripts are available, right? So you can just note down the formulas and watch the formulas. So it will like help you like understand like which formula you can use it, like when something is given, when redundant data is given, something like that. It will be helpful that way.
Actually, ma'am, in the exams we have a very limited time. So, if there may be many numerical questions, so it will be typical to solve that questions in exams. That's why I'm asking. Ki in exams will be so many numerical questions will come out on the basis of theoretical question.
Mm, I don't know like how the questions will be set and all, because I'm not involved in like any of those things. But mostly they won't be asking very like hi-fi questions. It will be based on your understanding level. Like you have to
In that
understand the concepts.
there
That's more than enough. Huh.
in the assignments are there are also so many numerical questions. So during the solving of that questions, I took around 3 to 4 hours. So
Okay.
I'm just, I'm just thinking ki in the exams, if that kind of numericals will become, then how we will be able to solve that?
Yeah. It's you have to just practice only, Pooja. Like,
We have
yeah.
family.
Yeah, I think the grading is
Actually,
relative only, right?
Yes, ma'am.
So if
actually, all these problems are too technically overloaded. So if someone
Mhm.
is not from an environment background, so I think so it's going over the head. So
Mhm.
I have the operational experience in the wastewater treatment plant, but I am from a mechanical engineering side. So I think for me it's a very too loaded.
okay. Yeah,
Okay, we
it's
will do more practice about that
yeah,
so that
because it's
But
like
actually,
MTech
Pooja,
level. That's what the course is like advanced wastewater treatment. Like it's like you have to understand it. This is like MTech course. Actually, in IITs in IIT Madras, it is a MTech course. But it's not like you people cannot study. You can study. See, basically, it's going to be relative grading. If someone spends like 3 4 hours to spend like to solve your assignments, if someone is not even solving the assignment and giving exams, obviously you will get like more score, Hana. And see, you are attending the live sessions also, so like you will be able to like get more stuffs into yourself, so you don't worry about marks and those things and all. You can like manage with those things. It won't be an issue. Thing is, you try to understand the concepts. That is the thing. You watch the lectures, understand the concepts, attend the live sessions, do the assignments properly. Obviously, you will get good grades.
Okay, ma'am. Okay.
Okay, you don't worry about those things alone. Okay, chalo. Now we will move to the next question. Dash gives substrate removal rate per unit solids in the system. Can someone tell what is the answer? Okay, I'll give some time.
Okay, I'll give some time.
Maybe you can think for like 2 3 minutes. After that, I will explain how it works.
is option C.
It is option C. Can you tell how it
Can you tell how it
came? Option C. Can you explain?
Basically, the food
basically
to
the food to
microorganism ratio is
microorganism
the
ratio is the
ratio of the
race?
mass upon volume.
Huh. Yeah, you are correct. You are correct, Bhupenda. So it is like dash gives the substrate removal rate per unit solids in the system. See, in the system, what is getting uh, removed? Substrate. And substrate is nothing but food to the microorganism. And solids in the microorganism will be your biomass. It is basically the biomass, right? Because inside your reactor, just a second. So inside your reactor, what is happening is basically you are sending in some substrate and you are producing biomass. X will be here. So what you are sending is your substrate inside. So your substrate is getting consumed Your substrate is getting consumed by the bacteria present inside the reactor to produce more solids. The bacteria will be suspended solids. Hana? So your soluble organic matter is getting converted to suspended solids. So it is basically your substrate is getting removed as food to the bacteria. So that is why in the numerator it will be food. To microorganisms ratio, because the solids produced is nothing but the microbial cells only. So it is option C, food to microorganism ratio. Can you understand what I'm telling, Pooja?
Yes, ma'am. I got it. The FM ratio.
X by M ratio. Yeah, that's it. So your answer will be food to microorganism ratio. Okay. So last two problems, I want you all to like solve it literally. It may be a bit difficult, but it will be very helpful for your exam point of view and to understand the concept very clearly. Okay. So I want you people to solve the problem like with hand. I'll give some 10 minutes time for both the problems and then I'll explain it again. First I'll tell how to do the problem and then maybe if you have some Excel sheet, if you are using laptop to like watch the lecture, you can like use an Excel sheet to get the answer, or maybe you can just do some manual calculation and tell me the approximate answers. So first the question is find the K value for the first order reaction rate given the variation, that is the concentration with respect to time. How does it vary? It is given. So at time t is equal to 0, the concentration will be 0.6104. At 30 minutes it is 0.3094. Sorry, yeah, we will remove this point. 1 second. 30 minutes point is not required. At 60 minutes, it is 0.3047. At 90 minutes, it is 0.2136. And at 120 minutes, it is 0.1446. So what you have to do is, you have to find the first order reaction rate constant, that is K. So step 1, you have to calculate C by C naught value. Second, you will have to calculate ln of C by C naught value. And third step is you will have to make a plot between time and ln of C by C naught. The C you will be considering is the C at a particular C will be at a particular time and C naught will be your 0.6104. Okay. Did you people understand what I'm telling?
Ma'am, firstly, just elaborate the questions. I'm not getting the question.
Okay. See here, you are given time with respect to time, how the concentration of the pollutant varies. Okay. Okay. See, there is some
Okay.
degradation happening. Okay. There is some degradation happening and initially 0.6104 concentration is the concentration of the pollutant present. Okay, with respect to time, as the degradation is happening, the concentration is coming down. If you see, Hana, as the time increases, the concentration decreases. Okay, so it is like 0. I mean, at the end of 120 minutes, it's going to be 0.1446. It is decreasing like this. Okay. So now what you have to find is Assume this degradation follows first order kinetics. Okay, so this follows first order kinetics. Do you know what is the equation for first order kinetics?
It's ma'am, you have earlier explained dc upon dt.
dc upon dt equal to
Minus k. Minus k.
k minus k into c, है ना?
C concentration. Yes, ma'am.
So it is c to the power 1, since this is first order reaction. Okay, so you just try to integrate this one. Okay, so in from this equation, if you see, dc by c equal to k into dt. Okay, so if you integrate on both the sides, you will be getting ln of, you can keep this as c and c naught, ln of, if you integrate, you will be getting ln of c by c naught is equal to kt. Okay, sorry, it's minus kt. So this will be your equation for first order reaction. Ln of c by c naught is equal to kt. Okay, so what you have to find here, it is asked in the question, is your k value. This k value you have to find. So if we make a plot between time versus ln of c by c naught, you will be able to get the slope. Hana, that will be your k value. Can you understand what I am telling? Pooja,
Yes, ma'am.
you can copy this derivation also. Right? dc by dt is equal to k into c. Okay, so if you try to integrate, dc by c is equal to k into dt. If you integrate, you will be getting ln of c by c naught is equal to k into t. Obviously, your k will be negative here since it is a degradation process. Is it fine?
Yes, ma'am.
Okay. So now I'll tell the steps how to solve this problem, and I'll give 10 minutes time because it will take some time. It is a a difficult problem, not difficult. It's a bit more numerical problem. So I'll give some time. First I will explain what you have to do. Calculate C by C naught. Okay. So C naught will be, your C naught will be this one. This will be your C naught. Okay, you make one more column like C by C naught. One second. and then ln of C by C naught. You make two more these things like this. Okay. Now you find C by C naught. Okay. For first case, C naught will be constant for all the things. It is going to be 0.6104. So your C naught will be 0.6104. Your C will be this 0.47. Again for this it will be this one. Your C will be varying. Okay. So initially if you find C by C naught for time t equal to 0, you can calculate. C by C naught will be 1 because here C is also 0.6104 divided by C naught is also 0.6104. When it comes to this one, your C will be changing. That is, your C will be for this it will be 0.3047 divided by 0.6104. So it should be 0.3047 divided by 0.6104. So it will be 0.4998. Here it will be 0.4998. Did you get how I'm calculating this? Or should I explain once
Yes,
again?
ma'am. Yes, ma'am. No, ma'am. I'm getting this.
Okay. So now you try to fill this tabulation. I will give some 10 minutes time. Now it is 8:24. Like I'll give time till 8:30 maybe. After that we have to plot also. We need time. So I'll give time till 8:30. Just fill this tabulation. After that I'll tell what to do.
Ma'am, for the 90 minutes, it will be 0.7010.
1 second. 0.7010.
It will be 0.2136 divided by 0.3047, na?
no. It will be 0.2136 divided by 0.6104. The C naught will be
Okay, we
constant.
had to calculate. Okay.
That's why I wrote the C naught value as 0.6104 constant.
It will be constant. Okay.
That will be constant. Your C will be only varying.
Hello.
Hello. Yeah, tell me, Pooja.
0.34, ma'am.
0.34. Wait, let me check the answer. 0.34. Yeah, it is correct. Then next one. Next point. What will be the point? Calculate for the next point also, Sneha. For this
Ma'am, it's 0.2368.
Yes,
2,
ma'am. 0.2368.
fine. Now you find ln of C by C naught. Ln of C by C naught for 0 will be, for 1 will be 0, right? Here it will be 0. Here what will be the answer? Ln of 0.4418. Point 49918. We have to find ln. What is the answer?
Ma'am, for last one, minus 1.44. Yes.
Huh. Or is everyone getting this answer which I'm projecting? Pooja, Bhupender Singh,
37. Yes, ma'am.
okay. Now
Yeah.
you try to like plot these values in the graph. If you don't have a graph paper, just in your rough note itself, you can just make some equal measurements and try to make a plot between uh, time and then ln of C by C naught. Okay. I'll just give some 5 minutes time for that because it will take some time. Maybe I'll give 3 to 5 minutes. You just make a plot. Megha, are you understanding what I'm teaching? Meha Pradeep.
Yes, ma'am.
Okay. If you're not understanding now, let me know at that moment itself. I think this is the first time you are attending the live session, right? Meha?
Yes, ma'am.
Okay. Did you join the course later?
Yeah, I could only join last week.
Okay, okay, no problem. I'll project the uh, values also. You just try to make a plot, everyone. Have you people plotted? Pooja?
Yes, ma'am. I'm just putting the points.
Okay, okay. Okay, fine. No problem. Take your own time.
Okay, ma'am, I have plotted
Okay.
now. Hmm.
Can you tell me what is the approximate slope, Pooja?
Slope in the sense means, ma'am.
Slope in the
Like,
sense. Wait, I will tell what is slope. Wait, I'll show the answer because I have one more problem.
that's the
Because after that I have one more
minus one
problem
point.
which is also a big numerical. So see, slope is basically, now you have got a line, right? So this line, what is the dx by, I mean dx by dy by dx? Okay, it is basically what is the distance here in y-axis, that is approximate distance here divided by distance here. That will be your slope. If you plot it in Excel, no, it will like directly show the slope. Or if you take this point and this point, wait, let me try to like tell you numerically. If you take this, these 2 points, you take, okay, 90 and 120. It is like you use the calculator and find what is the difference between these two things. Okay, so it is minus 1.44014. You try to find the difference between this two and this two. If you find the difference between this two, it is 90 minus 120. It's going to be minus 30. Hana? If you
Hmm.
find the difference between this and this, it's going to be minus 1.05001 plus 1.44014. So it's going to be 0.39.
Hmm.
है ना? 39013. So your slope will be basically this value divided by 30. So if you do, you will get the approximate slope. Okay, but what exactly you have to do is you have to find the equation of this line. This is a line, no? So we will be getting y is equal to mx plus c. C will be approximately equal to 0, negligible here, because the origin is time is 0, na? So at origin first point is 0, 0 comma 0. So C will be negligible. So you have to make a plot between y and x, that is ln of c by c naught versus time. If you put the slope, no, it will be, this is how you have to calculate the slope manually. Okay, if you do this, you will be getting approximately, I think, 0 point equal to 0 0.013. Hana, here we are, if we do more accurately in Excel, you will be getting it as 0.0118. Okay, so like this is fine, still this is fine, because we are doing manual calculation. If you put in Excel, you will get exactly 0.0119 or 118, something like that. Is it fine, Pooja?
Yes, ma'am.
This is how you have to find the slope. You can like approximately tell, but usually it's better to like fit it in Excel and then like calculate the slope. Okay, in the exam and all, mostly if they ask, they'll be asking only up to 1 or 2 decimal points. Okay, so you won't be like you don't have to worry about those things, I guess. See, in option, if they give 0.04, 0.01, 0.1, 0.4, obviously you will be able to get approximate value, this one 0.01. Okay, so you don't have to like worry about those things and all. Now we will move to the next question. This will be the last question for the session. We are given time, okay, 0th minute and 10th minute. What is happening to your X? This is biomass. With respect to time, your biomass is increasing. With respect to time, your biomass is increasing. And your COD will be decreasing. That is, this is your substrate. What will be your growth rate? Okay, growth rate. What is the formula for growth rate? Can someone tell me? It is mu, right? Growth rate is mu, which is nothing but dx by dt. Dx by dt by x. This will be your biokinetic parameter mu. You have to find this mu only. Okay. So, see here, we have limited time. So, I'll just explain how we got the answer. Okay. With respect to time, the biomass concentration is increasing and COD concentration is decreasing. You try to find what is dx by dt. Okay, so dx by dt, how will you calculate? It is nothing but difference in biomass concentration divided by difference in time concentration. Okay, so your dx by dt will be 405 minus 380 divided by 10. Hannah, so can you calculate and tell me the value? Pooja?
Just a minute. Actually, I am handling it with the phone same.
Okay, okay, no problem, no problem. Sneha?
Yes, ma'am, doing. Wait a minute.
Yeah. I'll wait, I'll wait.
It's 367, ma'am.
Arey Baba, how will you get 367? 405 minus 380 divided by 10. What is 405 minus 380? It is 25, right? 25 by 10 is 2.5, na?
Yes, ma'am, it's 2.5.
Pooja?
Okay, yes. I was incorporating data wrongly.
Okay, no
It's
problem, no problem, no problem. Okay, so your dx by dt is 2.5. Now you find what is your ds by
2.5.
dt. ds by dt, how will you find? S is nothing but your substrate, Hana? That is your COD will be your substrate, S. Okay, so it is ds by dt. It is ds, this is dx by dt. This is dx by dt. Your ds by dt will be your ds by dt will be 935, that is change in substrate concentration divided by change in time. So it is going to be 935 minus 902 divided by time, that is change in time, that is 10 minus 0. Can someone calculate and tell me the answer? 935 minus 902 divided by 10.
Ma'am, it's 43.3.
Arey Baba, how will you get 43.3?
935 minus 502, right?
It is 902, ma. Here, see here.
Oh, okay.
Ah, so 935 minus 902 divided by 10.
3.3.
It is correct. 3.3. Okay.
3.
Yeah. So this is 3.3. Now you find what is the average for x. Average for x will be, x average will be 380 plus 405 divided by 2. Three 80 plus 405 divided by 2. Can someone tell me what will be the answer?
392.5.
392, ma'am.
Yeah, it is 392, Pakka. Now you find
Yeah.
what will be average S. Okay. So average S will be 935 plus 902 divided by 2. Hana? So now you tell me what will be the value for this average S. Just calculate and tell me. Do the calculation, because I will also check the answer. Maybe my check answer can be also wrong. So Do the calculation and tell me. 935 plus 902 divided by 2. How much you people are getting?
Ma'am, it's 918.
Cool. It's 918.5. Okay. Now, what is the
Yes,
formula for
ma'am.
mu? It is dx by dt divided by x. Hana? You don't require this averages. Sorry about that. So, dx by dt divided by x. So, you know what is dx by dt? It is 2.5 divided by x. It is 392.5. So, if you put 2.5 divided by 392.5, you will be getting mu. Can someone calculate and tell me what will be the answer?
Ma'am, it's 0.006.
Cool. So, that will be your answer. So, this will be your answer. Okay. Understood? Pooja, did you understand?
Yes, ma'am. Yes, ma'am.
Okay, so this is how you have to calculate. So that's all the problems I have. Thank you so much for attending the live session. If you have some doubts, you can ask me now.
Hello, ma'am.
Yeah,
Ma'am, actually, I told you no, I joined lately, so I have missed two assignments, first and second assignment.
okay.
Deadline is over, so I won't be able to get it. Then how you will be considering the six best assignments, right?
I
So,
think yes. Yeah, so that won't be an issue. Like if you give these remaining assignments properly, you will be able to get good score in assignment, I guess.
okay, ma'am.
Don't worry about those things and all. Like it's fine. Like anyway, it's best of six only, right?
Okay, ma'am.
Uh,
Ma'am,
yeah.
can you help me with my college project problem?
Which one?
We are doing project on East only, ma'am.
Okay. So what do you
Uh,
want me to do?
East growth analysis we need to do, ma'am. So at maximum growth condition, we need to add some elements to the yeast for conversion of inorganic to organic elements.
Okay.
How we can find the maximum growth rate at the peak level? That's you shown no graph no ma'am.
Okay.
Log
So
phase,
yours
back
is a
phase.
batch process.
Yes ma'am, batch process only.
Okay. So you have to find the maximum growth rate,
Yes madam. Uh,
right? See, you can make some Excel like this, okay? What you do is,
yes.
for with respect to time, you measure the yeast concentration and you measure the inorganic. See, you will be adding some inorganic substance, right?
Yes madam.
What is the inorganic substance you will be adding?
Selenium.
So that selenium will be your substrate, right?
It's not a source ma'am. It's a material. Need to convert.
Okay. See, selenium, the yeast will be consuming your selenium or what?
Yes madam. Yes.
Yeast will be considering your consuming your selenium, right? So your substrate
Yes.
here will be selenium. Okay. So instead of
Yes.
COD, you can just put as selenium. Okay.
Yes, madam.
Okay. And your instead of biomass, you can put it as yeast. Okay. So
Yes,
all you need is only this much data. Okay. With respect to time,
madam.
how your yeast is growing, how much selenium is being consumed. Yours is a batch process, right?
Yes, madam. Yes.
That is, you will be putting one inside one beaker or some conical flask, something like that,
Ah,
right?
yes, madam.
So how will you do the process? First you will add some initial yeast, then you will add some initial selenium, and you will be measuring how the selenium is reducing with respect to time, right?
Yes, madam.
Okay, so if you have these three data, no, you can like make all these other things and then make plots to get maximum substrate rate, like sorry, maximum growth rate.
Ma'am, how can we predict that yeast is at after log phase? It's lag phase after log phase. It
You
reach
have
its
to just plot it.
stationary phase.
Yeah, you need data with respect to time.
How can we get that? Where will we get from that?
You have to do
Uh,
experiment and get time.
yes, ma'am. But
uh,
how we are measuring using that OD, ma'am, optical density?
See, you have to read papers. Okay, you have to read papers like
Yes,
at
ma'am.
what OD your yeast will be like present.
Yes, ma'am.
Those things and all you have to read paper. Okay, and get,
Good.
see where how you will be doing your experiment is in your beaker. You will be adding this
Ah,
yeast and selenium and measuring with respect to time what is the yeast concentration and selenium concentration.
yes, ma'am.
Okay, so this,
Yes, ma'am.
from this data you can generate all this data.
Yes, madam.
Okay, see dx by dt, how you will be finding is your change in yeast concentration with respect to time. The last problem I explained, right? Did you listen to it?
Yes, madam. Yes, I saw that
That
example.
is the thing. See here, with respect to with respect to uh, time, how your yeast concentration is varying, that you have to calculate here in this column. And with respect to time, how your substrate, your selenium is getting consumed, that you have to calculate here. Okay, then find average yeast concentration, that is your this x x1 plus x2 divided by 2. Okay, that's how you have to fill this column. And average S concentration, that is your substrate selenium concentration, with respect to time, how does it vary, that you have to write. Then you can find dx by dt by putting this average x divided by dx by dt. Okay, that's how you have to fill this column. Then substrate utilization rate you have to find, that is ds by dt
Yes, madam.
divided by s. Okay, this is divided by x also. What is your name, by the way?
Vishwanath.
Okay, you do one thing, you mail me. Okay, you mail me regarding
Yes,
this.
ma'am.
I think it will be too much for everyone to like if I explain it here. I'll
Yes,
type
ma'am.
my
Can
mail
you?
id.
Yes, ma'am.
It is actually out of the course. Okay, this I'm like
Yes, ma'am.
uh 1 second. You note down this email id and contact me through mail. Okay, I will like
Yes, ma'am.
explain you, okay, how to like
Okay,
solve this
madam.
problem. Okay,
Okay.
have you noted it down?
No, ma'am, it's not showing anywhere.
Check in the message box.
Yes, I got, madam.
Okay, just take a screenshot. Now I'm closing this session.
Yes, madam. Okay.
Okay. Have you
Thank you,
noted?
madam.
No problem.
Yes, madam.
Thank you. Thank you.